Hello and welcome back to our continuing adventures on the Let's Defend platform. Today we are taking a crack at the Malicious Web Traffic Analysis Challenge. This is a medium difficulty challenge with the description of, during a cybersecurity investigation, analysts have noticed unusual traffic patterns that may indicate a problem. We need your help finding out what's happening, so give us all the details. And this is on a Linux VM, typical aspect, challenge file folder on the desktop with capture.7-zip. Oh, and they've actually got a write-up. Or boy, null wire. Okay. I've done partial pregame in terms of starting up the VM, pulling the files off, and then terminating the VM, so we won't have to go through that, since this is effectively just crawling through Wireshark and Network Miner. Yes, the good old duo. So let's see. From the capture.pcap that we're given, which is extracted from that capture.7-zip, standard password of infected, if it actually was password protected. I don't think this one was, which would make sense as to why they're not calling on a password. So what's the IP address of the attacker? The IP address of the web server. The attacker first tried to sign up on the website, however he found a vulnerability that he could read the source code with. What's the name of the vulnerability? There was a note in the source code. What is it? After exploiting the previous vulnerability, the attacker got a hint about a possible username. What username, or what is the username the attacker found? The attacker tried to brute force the password of the possible username he found. What was the password of that user? Once the attacker gained admin access, they exploited another vulnerability. Jeez. That led the attacker to read internal files that were located in the server. What payload did the attacker use? It looks like local file inclusion, typically with the ... slash ... slash ... slash to keep working its way back in the file system to actually break out from where it's at. Attacker was able to use or view all users on the server. What is the last user that was created on the server? And then the attacker also found an open redirect vulnerability. What is the URL the attacker tested the exploit with? All right. So, all that for all this. So let's bring up our tools of the evening that have already analyzed the PCAP. And I gotta stretch stuff out. I know you guys can't see it yet. Here, let me do the transition. And bing, bang, boom. Okay, so we got Network Miner. So there was a discussion of a found username. So we're going to cheat. And we are going to take a look at what's the password, or what's the username, what's the password. And it looks like this is in sequential time. Yes, by the looks of it. So it looks like the username was admin, the password was MySpace. Okay. It looks like the server is 10104, as I know that IP address was talked about in regards to. So let's see if we are even remotely close given what's there. So again, I know we're going ass backwards at this. Admin. MySpace. No. Okay then. I thought that was the last one that was there. Yeah, it's the last one that's there. That doesn't, I guess, necessarily mean that would have been the one that worked. But are they? Yeah. Okay, well, we got part of it. Admin. All right. So then I guess the question becomes, we need to start taking a whack at what they want. So they want the IP address of the server as the very first portion. And if we take a look, so you could probably do this just about anywhere in here, but we'll go hosts. We can see that 10.1.0.4, which we observed previously underneath the credentials section of Network Miner, goes back to a letsdefend.eastus.cloudapp.azure.com on a Linux box, and also gives us the IP address of 172.208.113.81. So if we take a look at the formatting that they want for this particular question, and I just realized this is going to be something of a pain in the posterior, having to go back and forth like it always is. But so we can see here that we've got that particular aspect. So we are going to take a whack at 10.1.0.4. Yay! And now we want to figure out, okay, what is the attacker? And if we go back to Network Miner, I will try to go through and approach this from the Wireshark aspect as well. So in the event that for whatever reason, if you can't use Network Miner, maybe, and I'm sorry, no, all we give you is Wireshark and a PCAP. Okay, but if we take a look at Network Miner back underneath credentials, we will see, pardon me, the client IP. So that is the attacker, because that is who is responsible for attempting to brute force the password of admin on 10.1.0.4. So that would be 197.32.212.121, hopefully. So let's knock Network Miner down. We will transition over. So 197.32.212.121. Hooray. So I guess the big question is, okay, for that particular aspect, how can we figure that portion out in Wireshark? So I mean, if we take a look, and we know that this is traffic, so we're just going to apply HTTP. We can see a good deal of traffic, but what we see is 10.1.0.4. And we start seeing a bunch of stuff for 168.63, so on and so forth. Is there anything in here that would actually... So then we've got to actually figure out, okay, so it looks like other things talk this too. 168.63, 129.16, which if I take a look at Network Miner, 129.16 doesn't give us much back. Oh, So this is them going through and do the brute force. So I guess if you take the test to, or use the test to take the test, they mention the aspect of brute forcing. And what we can see is a bunch of HTTP 1.0s, and if we expand out, we can see login.php. So we can use that particular aspect. What if we take a look at yeah, and that's not going to come through. Of course not. But effectively, let me see. What can I quickly realign? So this is the Wireshark conversations for our PCAP capture. I mean, usually I would look at this and be like, okay, who's got the most traffic? I would almost think it would be, I mean, we can here identify the server as, okay, the one constant across all of them is the 10.1.0.4. And I realize that this is got me cut off. Wow, it actually became like a massive window. Okay. um, and if I were to take a look at this, I would see, okay, we're talking bytes, most packets, bytes, everything else like that. I would probably think that would end up just by the amount of conversation, but apparently it's somebody else because of the fact that we're using both tools to do the analysis and also the text or test or the challenge questions to sit there and try to gather further answers. Because remember, Network Miner showed us who was making the requests for all those various admin and then the various passwords in a brute force attempt. And that's the 197.32.212.121. Although total packets is actually well over, basically double between the web server and the 168 address. And then the 169.254, isn't that the hey, I can't get an actual IP address and I don't have a manual one set, so that's my fallback. Yeah, but so okay. That would be one way to go about it in all this. Okay. So attacker tried to sign up. So let's do this. It's going to be web requests. So we're going to go HTTP and IPADDR, short for address, space equals equals, and we're going to put the attacker's IP address in. So the 197.32.212.121. And we're going to run that through. And that limits what we've got to sit there and dig through. 2% of the packets are now displayed. That seems like a pretty good filter for what we're doing here. So, right, try to sign up on the website. So we would be looking for a sign up, register, and the like. Okay, we got login, register. And so we're looking for is there anything extra in here that we can use? Register, register, register. Yeah, not so much. And so, oh yeah, I gotta move this over here, or else you guys aren't gonna be able to. And this, not conversations. I need to follow. Follow the stream. All right. So we're looking through these. So they submitted admin password administrator. Okay, so it's not the first one. Hey, look at that. That looks like the answer to one of the previous ones. We'll come back to that. So it's not the first register. How about the second register? Sorry, blank is already registered. Name Ahmed. Interesting telephone number. We're just gonna start flipping through streams here. Okay, never mind that. That's taken way too long. So let's just stay on target, I guess, and let's just keep looking at the registers. So let's see, we're now on the next post. No. Well, I have to imagine that sooner or later we're going to find the right one. admin@gmail.com is already registered. Okay, well, I mean, they're trying. I'll give them that. They're trying. And here's our last one, at least for those that are close by. Okay, that's an interesting one. Let me get that brought up. Transition this through. Entity XXE system PHP filter convert base 64 encode resource. And I've seen XXE before in a few of these, but this seems to be like this is coming. So what is this a XML external entity injection? Really? Yeah, because it has the same type of, where it looks like it tries to call something else. Um, okay, this is interesting. So what is the base 64 encoded item that it actually gives us? I got CyberChef loading up in the background. Maybe. Okay, so take count of what's there. And then if we take a look at this port swagger where they talk about and they give the example, it's the same setup. So we get the doc type, replace. Of course, this one is a stock check, but then it's got the bracket, the entity, XXE system, and then points to something else for the registry. Or register.php. Yeah, so it could be used to exploit to retrieve files, perform server-side request forgery, exfiltrate data out of band, retrieve data via error messages. Excuse me. And you can use it to extract password. Okay. CyberChef is still working on it. And yes, I know the window just went away. Come on. I mean, this fits, right? Or am I just entirely out of left base? A vulnerability he could read the source code with. I mean, that seems like that would be code, and it looks like it would match XXE. It's 3. Okay. Come on, CyberChef. What the hang's going on here? Oh, it might be time to get another daily driver laptop. Okay, CyberChef came up, and we've got the base 64 loaded. And we get what looks to be PHP. Looks like it's taking name. And we get a note, admin, the comment lets you know that we updated your credentials with a very secure password, so no one can brute force it. So that's where we would get the admin from, that we were able to pick out with the network miner. Note, submit me as the answer. You got me. So that's the special code. Yes? Yes. Yeah, I paused this and came back. After exploring the vulnerability, got hit up on a possible username that was admin. So Then we're trying to figure out the password that was used. And then that's going to be the problem. We will have to find that out. But we're down to the last couple. What is this, last 4? Yeah, last 4. So let's see if we can go back to that local file inclusion. Bring Wireshark up. Alright, so where was the big local file inclusion? And then there's the redirect. So the %2f are going to be the forward slashes. To pull etc password and it oh wait. Hang on. And it succeeded. With that being done, one of the questions was the last user, right? The attacker was able to view all the users on the server. What was the last user that was created on the server? And it's what we're looking at right here. Alright, there we go. So it looks like A1L4MFTW. Would be the last one, since they go in order, top to bottom. Okay. And then let me take that, and we're going to change the %2f's to forward slashes, which gives us if I can actually get it to, there we go. Correct. What is the URL the attacker tested the exploit with? Okay, now that one we were able to sit there and see in short order. Oh, goody. I've got to re-put in the... Uh-oh. That's not good. My external keyboard stopped working. 197.32.212.121. And we've got to go back to looks like evil.com. HTTPS. Oh, wait. That's at the very end of the local file inclusion. So https:// oh yeah. Evil.com. Wait, what? %3A, %2F, %2F. Oh. Missing the /. Okay, another jump cut. Okay, so back at this again to sit there and figure out the password that was used. So let's see. I have kind of cut this, or done a little bit of pregame behind the scenes, as it were. So digging through, I went looking for attempted logins. And managed to work out, so it looks like packet or frame 14639. They try to hit post login, or they do a post to login.php. They run, let me bring up the TCP stream following that, and we are given a 302 found. So it looks like admin and Fernando. I don't know if that's it, but that looks different over everything else I was digging through. And so if we were to take that back and like take a look at one of the other ones, follow HTTP stream, that comes up. Which one is this? This is 643, so that goes back to that. And we set this up here. No, that's not the right one. $644, there we go. No, 643 is the one that we want. Jeez. And so here they do, as an example, they're doing, again, post to login.php, username admin, password they're trying is, what is that, 5 zeros? And they get a 200 OK. So going through all of these individually, I came up to the 302. So let's see as to whether or not if the password of Fernando is what we are actually looking for. Oh, that was down the stack a little bit. But that was about the only thing that ended up looking different. obviously finding the needle in the metaphorical haystack. So seeing everything else be 200 and then the actual legitimate one be 302 as a response for found. This was nice. Granted, it's been off and on for about 2 or 3 days trying to get other stuff done. But so there we go. That has been, what is it, the 8 questions? 1, 2, 3, 4, 5, 6, 7, 8, 9 questions for the malicious web traffic analysis. So only need the PCAP, and then, I mean, you can do it all in Wireshark, but Network Miner has proven to be, I mean, well worth the discovery and use, the extra CPU cycles to crunch through that stuff, to sit there and use both tools to approach it. But obviously it doesn't hurt to sit there and utilize the Wireshark if that's the only thing that you have. I mean, if you really want to make it difficult, I guess you could sit there and try to do it with, what is it, T-Shark? The command line interface? But, so there we go. 9 questions answered for Malicious Web Traffic Analysis Challenge on the Let's Defend platform. And with all that being said, I will see everybody in the next video.